Hey, today we're going to be continuing on with Chapter 11. We're going to be doing two lessons again. They are a little bit shorter, a little bit easier than the two lessons that we did last week on Thursday. But these will be the last two lessons we'll do from Chapter 11. And then, like I said, the rest of the year, we're going to be kind of jumping around a little bit. We're going to hit Chapter 10 after this, and then we might have time for a couple lessons from somewhere else after we get done with Chapter 10. But let's go ahead and get started with 11.3 here. So last time we talked about areas with quadrilaterals, with triangles, rhombi, trapezoids. Today we're going to be working on areas of regular polygons and circles. So as it says here, in a regular polygon, the segment which, before I read this actually, if you remember, a regular polygon is any polygon in which all of the sides are congruent. So if you look at this pentagon here, in order to know that it's a regular pentagon, we would see that all of the sides are congruent. For today's lesson, they're either going to show you through the congruency symbols, they'll tell you, or because of what today's lesson is on, you can assume that they are regular polygons. So again, back to this. In a regular polygon, the segment drawn from the center of the polygon perpendicular to the opposite side is called the apothem. So in this example right here, from point A drawn perpendicular to one of the sides is called the apothem. In the figure at the right, AP is the apothem, and AR is the radius of the circumscribed circle. So a circumscribed circle is a circle that goes around the entire outside of the regular polygon. It'll hit every vertex of the regular polygon, and that point that's in the middle of the polygon is also the middle of the circle. So in order to find the area of a regular polygon, if a regular polygon has an area of A square units, a perimeter of P units, and an apothem of A units, then the area is equal to 1/2 times the perimeter of the polygon times the apothem. So I'm going to go ahead, we're going to ignore example 1 right now, and we're going to take a look at example 2 here. So it says, find the area of regular pentagon RSTUV above if its perimeter is 60 centimeters. So if its perimeter is 60 centimeters, then in order to figure out how long each side is, or what the length of each side is, since it's 5 sides, we can do 60 divided by 5, and that tells us that each side is 12 centimeters long. So, first thing we need to do is find the apothem. In order to find the apothem, the first thing we have to do is find the measure of the central angle. A central angle is when you take your regular polygon and split it into equal triangles, with each side of the polygon being a base of the triangle. So in this case, we would have 1, 2, 3, 4, 5 triangles. The central angle is what each one of these angles is. And in order to do that, we know that there's 360 degrees in a circle. It's split into 5 even or 5 equal angles. So we would do 360 divided by 5, which when we do 360 divided by 5, that would give us 72 degrees. So this whole angle right here is 72 degrees. But we need to know, in order to find this length right here, we need to know just what half of that is. So we can do 360 divided by 5 gives us 72. Then divide that by 2, and that gives us an angle measure of 36 degrees. So now that we know that, and we know that the base here is 12 centimeters, we want to know what half of that is, what the length of, we want to know what the length of segment RP is. right here, which is going to be half of the base. So that's going to be 6 centimeters. Now, because we know this angle, we know its opposite side, and we're trying to find its adjacent side, we need to figure out which trig function we're going to use. If we know an angle, we know its opposite, we're trying to come up with its adjacent, OA, O opposite over adjacent, is the tangent. If you think back to SOHCAHTOA, tangent is equal to the opposite over the adjacent. So that's where we have here the tangent of 36 degrees is equal to 6 over AP, or you could plug in x there. So then that means that AP, or x, the apothem that we're trying to solve for, is going to be 6 divided by the tangent of 36, which gives us 8.26. So now we know they told us that the perimeter is 60 centimeters. We just came up with the apothem of 8.26. That's the hard part, is finding the apothem. Now we need to find the area, which is just plugging in 1/2 times the perimeter times the area, or in this case, 1/2 times 60 times 8.26, which gives us an area of 247.7. They don't tell us what to round to, so on your homework, really, if you round to a whole number, a tenth, a hundredth, I would take any of those, but let's make the hundredth be the longest that you would leave the decimal. So let's walk through some of these on our own now. Let's take a look at number 1 here. It has a base length of 14 meters. So again, remember, area is equal to 1/2 times the perimeter times the apothem. So here, if we know that one side is 14 meters, it tells us that it's a regular polygon. So we can say that the perimeter, in this case, would be equal to 14 times 3, which is 42. Now the other piece of information that we need to know is A, which is the length of our apothem. So in this case, in order to find our apothem, we know that half of this base, the base of the smaller triangle we're working with, is 7 meters. We need to figure out what this angle measure is. Now again, you're going to take 360, you're going to divide it by the number of sides in your polygon, so in this case 3, then you're going to divide that by 2, because when we divide this 360 by 3, that gives us the angle for this whole triangle that uses the base as one of its sides. We only want to know half of that. So in this case, 360 divided by 3 would give us 120. Divide that by 2, and we get our angle measure of 60 degrees. So now we can say that the tangent of 60 degrees is equal to the opposite, which is 7, over the adjacent, which in this case we do not know. So now we could say that x is equal to 7 divided by the tangent of 60 degrees. Now I skipped a couple steps to get there. What we're doing is we're multiplying both sides by x to get the x out of the denominator. So then we have x times the tangent of 60 is equal to 7. Then we're dividing both sides by the tangent of 60 to get x by itself. So x equals 7 divided by the tangent of 60. 7 divided by tangent of 60 would give us, if I round it to the nearest tenth, that would give me x equals 4. So now I've got my two pieces of information that I need. I have my perimeter and I have my apothem, so I can go ahead and solve for the area. I would say that the area is equal to 1/2 times the perimeter, which is 42, times the apothem, which is 4. 1/2 times 42 is 21, times 4 is 84. So my area would be 84 centimeters. Again, since I'm finding the area, it needs to be squared. Let's go ahead and jump over to number 3 now. This one's going to be a little bit easier because it's a square. When you're working with a square, it makes it a lot easier to find the apothem. We don't have to do all of this division and everything in order to find, or we don't have to do the division, we don't have to use the tangent, because in this case, since this side is 15, we know it's a regular polygon, so this side will also be 15 inches. We know that this point is in the center of the square. So if this point is the center of the square, then the apothem is half of that height, which means our apothem is 7.5 inches. So in this case, we need the perimeter and the apothem. The apothem is 7.5. Perimeter is going to be 15 times 4, which is 60. So we would say the area is equal to 1/2 times 60 times 7.5. So 1/2 times 60 gives us 30, times 7.5 would give us an area of 225 inches squared. Now, the square is the only shape that works for. Every other shape, you have to do all of the steps in order to find the apothem. So let's walk through one more of these now. Let's go ahead and do number 5 here. So number 5 we're working with, it has 1, 2, 3, 4, 5, 6, 7, 8 sides. We're working with an octagon. So again, we can say we need to know what the perimeter is, and we need to know what the apothem is. The perimeter, we know that one side is 10. 10 times 8 is 80. So the perimeter is 80 inches. Now the apothem, again, in order to find that, we need to know what this side of the smaller triangle is, which in this case, it would be 1/2 of 10, which is 5 inches. And then we need to figure out what this angle is. Again, in order to do that, we're going to do 360 divided by the number of sides, which is 8, and then divide that by 2, and it gives us 22.5 degrees. So since we know the angle and the opposite side, we can now use the tangent of 22.5 is equal to the opposite, which is 5, over the adjacent, which is x. And then again, we can say x equals 5 over the tangent of 22.5, which gives us an apothem of 12.1. And our last step is just to find the area using that information. So area is equal to 1/2 times the perimeter of 80 times the apothem of 12.1, which would give us an area of 484 inches squared. So again, that's just a few of those. You can always go back and try out some of those other examples. Again, as you're going through on your homework on this, feel free to reach out if you need any help on those. The next thing that we're going to do is the areas of regular polygons and circles. So this one is going to be a little bit more simple than what we were doing on that last slide with the apothems. For this one, it's all going to be review of areas you've worked with in the past. So, areas of circles. As the number of sides of a regular polygon increases, the polygon gets closer and closer to a circle, and the area of the polygon gets closer and closer to the area of a circle. In order to find the area of a circle, this should be review. The area is equal to pi times the radius squared. Hold on just a second. So again, the area of a circle is equal to pi times the radius squared. So I'm going to go ahead and skip their first example and jump ahead to these exercises. Find the area of each shaded region, assume that all polygons are regular, and round to the nearest tenth. So for this one, what we need to do in order to find the area of the shaded region is we need to find the area of the entire circle, the outer circle, and then we need to subtract the area of the unshaded or the middle region. So to find the area of the entire circle, area is equal to pi times the radius, which for the whole circle would be 4 inches squared. So the area is equal to pi times 16. Now, most of you on the calculators that you're using should have a pi symbol. If you're using a graphing calculator, the pi symbol is right above the up arrow, which is called the caret. So you would push second, caret, and you should have pi show up. If your calculator doesn't have a pi symbol, go ahead and use 3.14. And then we would multiply that by 16. It says round to the nearest tenth. So the area of the outer circle would be 50.26, which rounds to 50.3. Then we need to find the area of the smaller circle and subtract that. So then we could do area of the smaller circle has a radius of 2 inches. So pi times 2 squared, which in this case would be pi times 4, which gives us 12.6. So now we would take the area of the entire circle, which was 50.3. We would subtract the unshaded region of 12.6. And that would give us an area of 37.7 inches squared. So let's do another one now. I'm going to skip number 2. Let's move on to number 3. So on number 3, we're given one big circle that's shaded with 2 smaller circles that are unshaded inside. So first, let's go ahead and find the area of the entire outer circle. In order to do that, we need to know the radius. They tell us that the diameter is 16. We know that the radius is half of the diameter. So the radius of the outer circle is 8 meters. So area is equal to pi times 8 squared, or pi times 64, which would give us an area of 201.1 meters squared. Then we need to figure out what the area of the unshaded region is. We know that we have 2 circles that are unshaded, that are both of the circles are equal to each other. So in order to find the area of those circles, we're going to do pi times the radius. The diameter of this circle is 8 meters, which means the radius of one of those smaller circles is 4 meters. So area is equal to pi times 16, which, if we look back right here, we know that that's 50.3. So that gave us the area of one of those circles. Now we need to multiply that by 2, and that gives us 100.6 201.6. So now we're going to do 201.1, oops, divided by, minus 100.6, and that gives us an area for the shaded region of 100.5 meters squared. So again, this should be some pretty good review for you of just, you've got a shaded region with an unshaded region inside, and you need to figure out what the area of the shaded region is. The last thing we're going to do here is the area of irregular figures, which irregular figures really just means it's not, most of the time, it's not just a circle or a square or something like that. It's going to be a combination of those. So again, an irregular figure is one that cannot be classified as one of the previously studied shapes. To find the area of an irregular figure, break it into familiar shapes, find the area of each shape, and add the areas. So I'm going to go ahead and jump down to the examples here. So on this first one, we have a shape that we can break down to a rectangle and a semicircle, or half of a circle. So first, in green, I'm going to go ahead and find the area of the rectangle, which would just be the length times the width, 34 times 15, which would give us an area of 510 feet squared. Then I'm going to find the area of my half circle, which really I'm just going to find the area of a circle and divide that by 2. So for the circle, it's going to be pi times the radius, which the diameter is 15 feet, which means the radius is going to be 7.5 feet. So if I go ahead and do 7.5 squared and multiply that by pi, that's going to give me 176.7. Actually, I'll go like this. 176.7. Then again, since it's only half the circle, I need to divide that by 2, which gives me an area of 88.4 feet squared. So now, since it's a composite shape, meaning we're not subtracting an unshaded region from the shaded region, we're finding the area of the whole thing, we would need to add those two together. So 510 plus 88.4 would give me a total area of 598.4 feet squared. So sometimes it's going to be like that, where you're going to have to find multiple areas and add them together. Sometimes, if we have a shape like this, we can actually move some pieces around to make it a shape that we're used to dealing with. And on this one, what we can actually do is we can draw a line in right there. And if you think about it, these two triangles, if we go ahead and cut them out and add them right there, we now have a shape that we're used to dealing with. This is a rectangle that has sides of 24 inches and 40 inches. So now to find the area here, we can go ahead and just say 40 times 24, which gives us an area of 960 inches squared. Now you could break it down into other shapes and find all the areas and add them together, but this is going to be an easier method, and then you only have to find the area of one figure. I'm going to go ahead and do 3 more examples here. So this one, if we look at this irregular figure here, if we think about it, we can cut this in half, or not in half, but we can cut it on that line right there, and we've got 2 separate triangles now. I'm going to go ahead and do one triangle here in red. It has a base of 38 centimeters and a height of 14 centimeters. I know the area of a triangle is equal to 1/2 times the base times the height. So for my red one, 1/2 times the base, which is 38, times the height, which is 14, gives me an area of 266 centimeters squared. Then I'm going to go ahead and do my second triangle in blue. The area is 1/2 times the base, which in this case is 40, times the height, which is 10. And that'll give me an area of 200 centimeters squared. So the area of the entire figure would be those 2 added together, which will be 466 centimeters squared. All right. Number 4 up here. If you look at this, we've got, again, 2 separate shapes. We have a triangle on the top, and then we have a square. So for the triangle, we know that all of the sides of the square are the same. So we can say that's 42, that's 42, and that's 42. So we know that the base of the triangle is 42 centimeters. In order to find the height of that triangle, right there, the height of the entire figure is 42 centimeters minus the square, which is 22, would leave us with a height of 20 centimeters for our triangle. So for the triangle, the area is 1/2 times the base of 42 times the height of 20 would give us going back here. You guys probably realized my mistake before I did. Those would not all be 42 centimeters, those would all be 22 centimeters. So 1/2 times the base of the triangle, which is 22, times the height, which is 20. Sorry for any confusion there. When I do that, I'm going to get 11 times 20, which will give me 220 centimeters squared. Then the area of the square, I'm going to go ahead and do in blue here, is going to be 22 times 22, which is 484 centimeters squared. Then I just need to add those 2 areas together, and I get a total area of 704 centimeters squared. Now I'm going to go ahead and do one more at the bottom here, because it's working with shapes we haven't worked with yet today. If we look at this, number 5 here, again, we can split it into 2 separate polygons by using that line that's drawn in right there. We know that these are both going to be trapezoids. If it's they say assume that all polygons are regular polygons. If it's a regular trapezoid, that means that we know these 2 legs will be equal and these 2 legs will be equal. So in order to find the area of a trapezoid, we need to know 1/2 times the height of the trapezoid times base 1 plus base 2. Now we have the base. Both trapezoids have one base of 40, and they both have a base of 20 on the top. We need to figure out what the height of that trapezoid is. We know since it's a regular trapezoid, or a regular polygon, sorry, that the sides are going to be equal to each other. So if the whole thing is 64 meters, we can say that each one has a height of 32, half of that entire height. So now we can say the area is equal to 1/2 times the height of 32 times base 1 plus base 2, which would give us 60. So 32, sorry about that, times 60 times 0.5 would be 960. And that gives us one of the trapezoids, but this is made up of 2 trapezoids. So we would need to multiply that by 2, which would give us a total area of 1,920 meters squared. There's your assignments for these lessons. Again, chapter 11, lessons 3 and 4. Homework will be due on Thursday. Make sure you get it turned into our Google Classroom. You guys have been doing a pretty good job of reaching out if you have questions, so continue to do that, and just let me know if you guys need anything.